All right, beautiful people. So today we're talking about how do you find equivalent ratios. So yesterday we talked about what a ratio was and how to write a ratio. So I want to remind you over in the side that ratio is pronounced ray, she, o. And don't forget to say it out loud a few times so that you know how to say it. So that when I ask you what a ratio is, you're not like, ratio? No, ratio. Okay, ratio. It is okay. This is a weird word, so I totally understand. All right, so we're going to start by talking about what does equivalent ratios mean? Equivalent ratios. Well, equivalent ratio means probably similar to what you think it means. This word equivalent comes from the word equa, or the phrase equa, or the root word equa, which means equal. Okay, so there are two ratios that have the same value. So two or more ratios that represent the same value or relationship. So I'm going to draw a diagram, and then we're going to talk about two equivalent ratios for that exact same diagram. Okay, so in this diagram, I have kind of squares and a bunch of circles. So let's just call them squares. So I want the ratio of squares to circles. Okay. All right. So I'm going to write the ratio of squares to circles. So I'm going to start with how many squares are there, because that's the first word here. Well, there are 3 squares. Okay. And then how many circles are there? Well, there's 1, 2, 3, 4, 5, 6. 6 circles. Okay. So the ratio of squares to circles is 3 to 6. However, you may have noticed that there's a little pattern happening here. I can split this ratio or this diagram into 3 equal proportions. Look at that. If I split it equally, then each of these equal segments has 1 square and 2 circles. 1 square and 2 circles. So this one's got 1 square and 2 circles. This one's got 1 square and 2 circles. This one's got 1 square and 2 circles. Altogether, there are 3 squares and 6 circles. These are equivalent ratios because they represent the same relationship. It's the same sort of thing. If I put like another set of a square and a bunch of circles, then I would have 4 squares to 8 circles. And this would also be an equivalent ratio. Okay, these are all equivalent ratios. So that's what an equivalent ratio is. So the question that we have now is, how do you find those equivalent ratios? So this is what an equivalent ratio is. How do we find them? Okay. Now, you might have already thought this, and if you haven't, that's totally fine. But maybe you're thinking, hey, ratios are like fractions. Because remember, we can write ratios as fractions. So if I go back up here to these ratios that we wrote, 3 to 6, this is 3/6. 1 to 2, this is 1/2. 4 to 8, this is 4/8. These are all fractions. Ratios are like fractions. And guess what? You can find equivalent fractions because we worked for 2 weeks on finding equivalent fractions. So all we've got to do is apply what we learned about equivalent fractions to find equivalent ratios. So you can find equivalent ratios by finding equivalent fractions. This is honestly probably the biggest key idea that we're talking about today. You can find equivalent ratios by finding equivalent fractions. So let's do an example problem. Okay, so this says are 4 to 3 and 20 to 15 equivalent ratios. Okay, so in order to see if they're equivalent ratios, we're going to do some steps. So step 1 is make them fractions. Because remember, you can write ratios as fractions. So 4 to 3 is the same as 4/3. And 20 to 15 is the same as 20/15. All right, I'm going to continue in the next video.